So today is the third webinar in our Globe Air Quality Campaign webinar series, and we'll be discussing how ground observations can enhance an air quality story. So we'll talk a little bit more about telling a story as well as talking about purple air and how to look at the maps and download data, and then the EPA fire and smoke map as well. Again, my name is Angie Rizzi, and I'm an outreach coordinator at NASA Langley Research Center, and I work on GLOBE with Dr. Margaret Pippin, who's the GLOBE air quality scientist. So, along the lines of focusing on air quality stories, I want to briefly revisit the elementary GLOBE stories. These are great for younger citizen scientists. In the book, What's Up in the Atmosphere? Exploring Sky Colors, students are making ground-based observations of sky color. Each elementary globe book is available as a PDF and an ebook, and this one also has a web story. Each book also has a minimum of 3 activities and 2 coloring pages. The activities for this book include Why Not So Blue, which explores the relationship between the number of aerosols and sky color. Sky Observers is another activity which guides students in observations at different times of day. The See the Light activity helps students explore some properties of light and the visible spectrum. And Up in the Air is the aerosol catcher activity we explored in the last webinar. The air quality story does a good job of explaining aerosols to students and relating them to sky color. I especially like the coloring page with aerosols from different sources. I also want to point out that there's good background content for educators in the book. The air quality index categories shown here in the middle are included in the background content. This is an important air quality concept that we'll revisit later. The books also do a good job of showing various science practices in the illustrations. These selected pages show the students making observations at different times of day and how they recorded those observations. Note that there are photos, drawings, journaling, and a data collection sheet. Continuing that theme, the story shows how the class summarized results in a chart. That is then related to sky color and the number of aerosols. The air quality index categories are also correlated with the number of aerosols, as you can see the little dots in the colors. I will say that the sky color changes near sunrise and sunset are strongly related to the properties of light, so that's something to keep in mind. Air Quality Book is a great support for cloud observations, as well as the elementary globe book, Do You Know That Clouds Have Names? This book introduces learners to the different types of clouds and can help them make cloud observations. The Cloud Fun activity prompts students to draw their observations of cumulus clouds. The Cloudscape activity helps students identify cloud types, vocabulary, and cloud heights. And To Spread or Not to Spread helps students learn about contrails. The coloring pages have different cloud types on them. The Clouds book has a lot of information in it. There are illustrations for the cloud types and teacher tips throughout. There are also great photograph examples of clouds and contrails, as well as indicators which show the level that the clouds being discussed would be in the sky. So in this example, they're showing a mid-level clouds. Coupling all of this with the sky color information really helps students with cloud observations. We just talked about elementary globe stories, and Kim Abels tells stories with her art. Her Shared Skies project takes sky photos from a variety of sources to show different sky scenes and make the point that our skies are indeed shared. This project shows a variety of scenes, and I really like it since it uses photos and we use photos in Globe. So we're going to explore some of the Globe photos now. Remember that you can see these photos in the globe visualization tool. The image here is an observation that was made, and the observer indicated that the sky was obscured by dust. This is an air quality issue which can be short-lived or last a little longer, and they can be small events or large events. And so since they identified dust, you can see dust in the picture. However, if they did not identify dust, would you have thought that maybe this was smoke or something else? Here are two photos that were taken from basically the same location at different times. Both of these observations were indicating that the observer saw smoke, but the pictures look quite different. And since we know the observer indicated smoke, then we could probably say that we see it in the pictures. But if they had not, notice that the first picture could easily be considered to be overcast. This picture here also is a picture where the observer indicated smoke. And as far as I can tell, I cannot really make out any smoke in the photo. It does not mean that there wasn't smoke, and it provides us with an opportunity to try to integrate additional data to tell this air quality story. This observation indicated smoke as well, and since it was indicated, you can probably detect it in the photo. However, if it weren't indicated, would you perhaps think that this was some sort of cloud? Here's another photo where the observer indicated smoke, and I would say that you can detect the smoke in the photo. And sometimes the smoke can look quite dramatic, as it does in this photo, where the observer said that there was smoke. However, notice that this color here could even be confused with a sunset picture, so you might want to pay attention to the time of day. And so what I'm trying to point out here with all of these different pictures is that the photos are great evidence, but we can integrate other data in order to build a powerful air quality story. So the first kind of data that we want to look at integrating is purple air. And we discussed how to get screenshots in our first webinar. We're going to go into more detail about purple air today. This is what the purple air sensor looks like, and you can see that it isn't that large. And I want to thank one of our webinar participants, Emily Holliday, who sent us this picture of her recently installed purple air sensor. If you go to the Purple Air website, you can see that they have some different sensors available, and there are two outdoor sensors. Margaret Pippin recommends the Purple Air PA2 for citizen science applications. The other instrument has some more technical issues surrounding the data and internet connections that are not really necessary for most citizen science applications. These sensors all send data to Purple Air every 2 minutes, and those data are used to update the maps and can be downloaded. And if you download 1 hour average data, you can compare those data to the EPA monitoring station data. Notice that when you go to the Purple Air map, that you can see instruments all over the world. This makes Purple Air a great way to augment globe data since both of these programs are happening around the world. And when the map comes up, it will default to the United States Air Quality Index. And that's what you see in the colors and the numbers there on the map. So the purple air color codes agree with the United States Environmental Protection Agency Air Quality Index category values, okay? So when it's the EPA PM2.5 AQI or Air Quality Index, the numbers displayed on the map will be in the index values. If you change your map data layer to raw PM2.5 and micrograms per meter cubed, which is preferred for our data analysis, note that the numbers are different than the index numbers. However, the categories remain the same. And so what this means is that if you change to the raw PM2.5, the numbers on the map will change, but the colors will not change. The colors should always agree with the EPA Air Quality Index categories. Some other countries have their own categories, but they're not displayed on Purple Air maps that I know of. Okay, so let's talk a little bit more about the map. When I go in to view the map, because I use it frequently, it sometimes zooms in on a particular area, but I'm going to come here to the US map. Now, we talked about these colors, and remember when you come in, the first thing you want to do is change from the AQI to the raw PM2.5 in micrograms per meter cubed. The next thing I want to do is turn off the inside sensors so that I'm only looking at outdoor sensors. Now, if I'm just looking at the map, it's fine for me to look at the 10-minute average. These numbers are updated every 2 minutes and they're rolling averages. So while we've talked about comparing 1-hour averages with EPA data, note that on the map, we're looking at rolling averages. If we download the data, we're going to get data that align with the EPA times. So in order to demonstrate for you a little bit more of the details, I'm just going to zoom in here, and I'm going to zoom in on Ohio a little bit, and in particular Columbus, Ohio. So if you notice, we have several sensors around Columbus, Ohio. So you can look at your local area and zoom in and see if you can find any sensors near you if you don't have your own. So I've zoomed in here and I've got several sensors in my screen that I can see. So if I wanted to get details of a particular sensor, I can click on the dot. This number here, 38, is the 38 measurement for PM2.5 micrograms per meter cubed. And you can see that it's in the orange part of the AQI scale. So if I click on the dot, I see that the 10-minute average is 38. It gives me information. It tells me some other values. It tells me the name of the sensor. And if you notice, there's a channel A and a channel B. And those two channels, I'm going to close this here, those two channels are both graphed on the graph. And you can see a few days worth of data. And if you see that those channels are agreeing very much with each other, that is a good thing, and that means that your instrument is functioning properly. So that's how you can get information. Now, if you want to look at a different sensor, you could click on a different sensor, and if you don't close out of this one, they're going to graph together, okay? So keep that in mind. If you close out of both of them, and then you look at your second sensor, then you'll only get that information on your graph. So you want to pay attention to that and make sure that you're not looking at multiple sensors at the same time if that's not what you're intending to do. So that's how you can find a sensor and find details. If you want to download these data, you're going to want to click on this down arrow. Now, I will caution you that if you have too many sensors on your screen and you have not zoomed in far enough, the download isn't going to be able to process for you, because when I click on this arrow, it's going to give me information about all these sensors that I see on my screen. So if I click the down arrow, you'll see that what comes up here are the different sensors that were on the screen. Okay, and so you'll want to pay attention to things like, are these data generally agreeing with each other and tracking each other or not? Okay, I am going to choose this first one that we were looking at to download. And let's say that I want to download from December 1st until December 9th. So I put my dates in. I'm going to come here and do 60-minute averages so that I can try to compare with EPA if I have a station available. I'm going to click channel A because that's the only one that we need to download for this monitor. I'm just going to choose this monitor and I'm going to click on download primary A. So these data will come up and you can save them on your computer, and we'll talk about how to process those data in a little bit. So that's what you need to do in order to download the data from Purple Air. So I'm going to pull up the file that we downloaded a little while ago, and I'm just going to step through some things that you can do to get these data ready to analyze. So the first thing that I always do is I come here and I will copy the entire worksheet into another worksheet. That's so that my original data do not get lost. And I'll rename my second worksheet I'll call it my graph worksheet. These are the numbers I'm actually working with. So I'm going to widen my column here for my date and time, and you notice it says that the date and time were in UTC, and that's great. However, it's going to be difficult to graph this when we have the date and time mixed in with some text fields. So I'll highlight this entire column and I'm going to come over here to find and I'm going to replace UTC with a space. So I just enter a space in there and I'm going to say replace all. Okay, so there did 210 replacements and now I have a date and time field. Now I can rename this field instead of created at UTC so that I will know that this time is in fact UTC. Okay. The next thing we want to do is columns B through H are not necessary for us. Okay. They're columns that the instrument uses for calculations and things, but I'm going to delete these columns. So now I'm left with two columns. I've got the UTC and I have the PM 2.5 in micrograms per cubic meter. Okay. If I select these two columns and I insert my graph, I would like to do a scatter plot with the lines attached. There we go. I have made a graph. Now, clearly, we're going to want to clean some things up here so that these dates are not overlapping each other and that kind of thing. But this isn't really an Excel tutorial, so just want to point out now we have the graph of our location for December. So I hope that that's helpful, and if you need any more details, I'm happy to help. Now I'd like to talk about the EPA fire and smoke map. And when you first go to the map, it will pull up the whole United States unless you allow it to use your location. So when you first look at it, there's quite a bit to see and it can be a little bit overwhelming. So let me go over with you what some of these layers are. If I click on the layers over here, there are permanent monitors, temporary monitors, and low-cost sensors. I'm going to turn all of them off right now just so we can see. Now we have large fire incidents and satellite detected fire incidents. So I'll turn those off and I'll turn the smoke plumes off, okay? So we can see the large fires and we can see where the satellites have detected. And today is not a day that has a lot of smoke activity. And this map is another thing that is real time. And so if you want to get big events, you need to go out when they're happening because you cannot go back into the past. Okay. So I am going to zoom in on an area today that I can show you how to do some things on this map, and then we'll go back and look at some screen prints of some other more dramatic days. So the first thing you might want to do is look at where does the EPA have permanent monitors? And this is where they are, okay? All these circles. The temporary monitors are monitors that the EPA puts up, and you can see that they are likely trying to respond to certain events that are going on with these temporary monitors. And then the low-cost sensors would be your purple air instruments and potentially a few other kinds of low-cost sensors. Okay, these are not regulatory monitors. And you can see that the density is quite a lot with these. So if I put on the permanent and the low-cost sensors, you can see where we have coverage. Notice here in this area that there are a lot more low-cost sensors than there are permanent. Okay, so I'm going to zoom in on Florida here, where I did see some smoke. And when you put that smoke map on, that's this layer over here, smoke plume extent, you can see where the smoke's going, okay? Now, what I like here is I'm going to put on just the low-cost sensors. And if you notice here in Pompano Beach, there is a low-cost sensor. And if I now put the permanent monitors on, I can see where there are permanent monitors quite close to the low-cost sensors. Sometimes, if they're co-located, the permanent monitor circle could even completely cover up a square for a low-cost sensor. So we see that we have some sensors that are located quite close to each other, and those would be great opportunities to get some purple air data and then compare it to EPA data. Okay, so we see this smoke here, which is very interesting. So since the day I'm recording this isn't a day where there's a lot of smoke across the US, I will show you a screenshot. This was taken on September 10th of 2020, and this is a screenshot from the EPA fire and smoke map. And you can see that there are smoke plumes going in quite a few different directions, as well as traveling across the country. And so again, you can identify the permanent and the temporary and the low-cost sensors on this map or these maps. And if you identify a low-cost sensor, you can even go to the Purple Air site, zoom in, find that sensor, and see what the readings are. Here's another screenshot from December 11th, 2020. And it's the whole United States, a general shot. I don't have any of the monitors showing so that we can see the smoke plume extent, but you can see that there are some areas of smoke in the south and in California. So looking in the south, we can see a bunch of smoke plumes, and you can look and see where there are permanent monitors or low-cost monitors near them. And in California, we also see some, and this one has a lot more of the low-cost sensors nearby. Here are all the sources from today's presentation. You can get a lot of additional information at these sites. If you have any questions about any of them, please feel free to contact us. We have a new email for the air quality campaign, lark-globe-airquality@mail.nasa.gov, or as always, you can contact us at our personal emails. Thank you for your time.